Alright, so welcome back to this series. What I've done is I've just reorganized essentially the entire project into smaller modules and files and made it a lot easier. So what this actually ends up looking like is if I can go ahead and run the worldgen.prx, and then I can do screenshot to test.bmp. And then if I go look at test.bmp, here you go, this is what it outputs. It's pretty simple, it just outputs a raw noise map onto the screen. Now, what my goal is actually going to be changing this to be something not only more detailed and more complicated, but also, I guess I'll change the visual representation as well in order to represent what like a landmass would look like. So the first step towards changing what it looks like would probably be eliminating this line and then replacing if the map value is less than half. For example, we'll say that the generated color is GU color 0.0, 0.0, and then it depends on the map value and 1.0. So the deeper the ocean, the darker the color. So now if we look at what test.bmp generates, it creates this image, which basically is doing exactly what we made it do before, which is that, anything that happens to be dark, anything that gets lower gets darker, for example, in the ocean, then anything that gets higher gets darker on the land. Now we can do plenty of different things, but that's a very basic sort of look at it. So what the method is going to basically do is if we have like more detailed terrain, this is basically a really nice smooth noise. What having additional octaves does is it makes this terrain way more complicated and way more complex. And the implementation behind that is a little bit more difficult. So I'm actually going to go ahead and change the generation to do, and then let's run it through the algorithm to basically zero this. So what happens when you get noise is that it goes from basically -1 to +1. To normalize that, you gotta add 1 to that and then divide it by 2. Because if you add 1 to it, it becomes 0 to 2, and then divide by 2 in order to get back to what your actual value is. So this would be normalized noise, and maybe I'll create an auto normalized noise is this, and then return the normalized noise. Now, this hasn't fundamentally changed any of the structure, but this is just an example of get noise. That basically changed nothing. That just made a method to make things easier. Now, what we could do is now let's try and make this noise more advanced. So what a more advanced algorithm would do would be something more like, for example, dealing with amplitude and frequency changes in order to calculate your noise better. So what I could do would be, let's just define a structure here for noise settings. And using those 4 settings, we can actually create an even more advanced form of noise. So what we could do would be like floating point, amplitude is like 1.0, and then the floating point frequency is equal to the, we have to add noise settings in here. So noise settings. Right, so we'll do noise settings, and then frequency equals settings dot frequency. And then we would have the sum of noise, and we would also do the sum of amplitudes. And then we would just run a for loop. We should add octaves. That wouldn't be a float. You'd probably want this for octaves. So for auto I equals 0, I is less than settings dot octaves, I equals plus. So you would just run it over this, and then what we do would do sum noise equals so we'll get a normalized noise here, and then inside of here it would be x times frequency and then y times frequency. So directly scaling the values here changes the frequency of your noise values. And then so that would be the normalized noise, and then you would also then multiply this by your chosen amplitude, so amp, and then the sum of amplitudes would be increased by the amp, and the sum of noises is increased by normalized noise. And then you would just say frequency, or sorry, the current amplitude gets modified by this value for persistence, so persistence, and then amplitude times frequency times equals the mod. I don't think there's a specific name for this, but the modifier for frequency, and then actually, let's say amplitude here should be the starting amplitude. But actually, we're not going to change that. Persistence is all we really need, so we can just get rid of that data structure, or that data entry. So then once we do that, now we can't, we want to get the sum of the noise, but then now it's times however many total amp we have, so it would be also divided by the sum of amplitudes. And as you can see, that added way more detail to the map and things like that. Like, this is by far a lot more detailed and a lot more interesting to actually look at. And you can technically stack these things permanently, and you can keep going, and you can mess with settings, and that will change all of the different attributes. But this is a really interesting field to play around with. Alright, so this is generated a little bit later, but this is actually a test result that I created, basically messing around with some of the noise settings. And basically what the gray is now is like sort of rocks or exposed mountains, and the white is basically just snow. I thought this was like a really cool example of, for example, of like what sort of terrain that you could generate, and the fact that it generates in about 1.1 milliseconds is also pretty cool. Either way, tomorrow I think I'm going to be working on trying to add biome maps onto this.